This is the second part of the notes for section 12.2, dealing with two-step and three-step mass-to-mass problems. So this is the first example I'm going to look at. We have the balanced equation up here. Here's the problem. 146 grams of HCl will form how many grams of hydrogen? Down here at the bottom, this is the general format that you want to follow. It shows the steps that you can take to make conversions, and it gives you an idea, depending on what's given and what you're looking for, how many steps it'll take to solve the problem. So in this case, for example, we have 146 grams of HCl that is given. So the given quantity is in mass right there. We're trying to find grams of hydrogen. That's what we want to find. Okay, that's also in mass. So if we look at this little chart here, it's going to take 1, 2, 3 steps to get there. So it's going to be 3 conversion factors. So on this one, the starting point, what you start with is going to be 146 grams of HCl. That's what's given. So our first step now, our first conversion factor is going to look like this: 1 mole of G over the mass of G. So the mass of G is going to be the molar mass from the periodic table. So we set up the conversion factor to look like this: 1 mole of HCl. And the molar mass of H is 1, Cl it's 35.5. So this number is going to be 36.5 grams HCl. Okay, that's step 1. So step 2, this is this setup right here. It's the mole ratio, just like what we did on the last set of problems. So it's always moles of what you're looking for, or moles that are wanted on top, moles that are given on the bottom. So we go up to the balanced equation. We're looking for hydrogen. So no coefficient listed there, so that's going to be 1. And you're starting with HCl, so that has a coefficient of 2. So this step looks like this. It's 1 mole of H2 over 2 moles HCl. And the third step now will look like this. So we set up another conversion factor, and it's going to be 1 mole of what you're looking for, what's wanted on the bottom. So 1 mole of H2, and we put the molar mass of H2 on the top. So that's 2.0 grams of H2. So there's our setup right there, all 3 steps. So take what's given, divide by the molar mass of what's given, mole ratio, multiply by the molar mass of what we're looking for. So now we can do the math, and well, we can cancel out units. So grams of HCl cancel, moles of HCl cancel, moles of H2 cancel, and it's just grams of H2 that are left. Now we do the math. It's 146 divided by 36.5. Take that answer, divide by 2. Take that answer, multiply by 2, and it ends up being 4.0 grams of H2. And there's our first problem. So here's our next problem. We have a different balanced equation to work with. And the problem is, how many moles of hydrogen are produced by 30 grams of lithium? So if we look at what's given, in this case it's going to be 30 grams of lithium right there. So our starting amount is going to be mass of G, mass of what's given. Okay. What we're looking for is moles of hydrogen. So in the previous problem we went all the way over to here to mass, but for this one we just want to find moles. So on this one it's going to be 1 step, 2 steps to get to where we need to go. So in this case we start with 30 grams of lithium. That's the given amount. Oops. All right, so 30. There we go. 30.0 grams of lithium as our starting point. So the first conversion will look like this. So it'll be 1 mole of lithium, and we put the molar mass of lithium from the periodic table on the bottom. Okay, and the molar mass of lithium is 6.9 grams. Okay, so there's the first step. Okay, the second step now is the mole ratio. So we set up another conversion factor. It's moles of what we want on top, and in this case we're looking for hydrogen. So we're looking for hydrogen, and we're starting with lithium. Okay, so those are the coefficients that we're going to use. So we're looking for hydrogen, so that goes on top. So 3 moles of H2, 6 moles of Li, and that's a setup right there. Now for the math, we want to cancel out the units, and it would be 30 divided by 6.9 times 3 divided by 6. And that ends up being 2.2 moles of hydrogen. So that's an example of a two-step conversion problem. This is that same balanced equation, but now this is another example of a three-step conversion problem. So we are looking for grams of lithium phosphate, and we're given 50 grams of lithium as a starting point. So we're going to start off right there, and we're going to end up right there. So this is going to take 3 conversion factors to get there. So go over here, and we're starting with 50.0 grams of lithium. Okay, set up our first conversion factor, and this is the setup right there. So it's 1 mole of lithium, and then the molar mass goes right there, 6.9 grams. Okay, our next step is the mole ratio, and we're looking for lithium phosphate, so that's right here. And we're starting with lithium, so that's right there. So those are the 2 coefficients that we're going to use. So it's going to be 2 moles Li3PO4 over 6 moles of Li. All right, that's that step. All right, the third step now is going to be right here. Another mole conversion using the molar mass. So it looks like this. Set up the mole, set up the ratio. We need 1 mole of that Li3 PO4 on the bottom. And then what goes up here is going to be the molar mass of Li3PO4. So we'd have to add together 3 lithiums, 1 phosphorus, 4 oxygens from the periodic table. That ends up being 115.7 grams of Li3PO4. Okay, so those are our 3 steps right there. Okay, now we'd want to cancel out units. Like so. And now it would be 50 divided by 6.9 times 2 divided by 6 times 115.7 to get our answer. And that equals 279 grams of that lithium phosphate. And that is our answer. So that's another example of a 3-step conversion problem.